All right, so today we're going to look at matrix determinants. Let me unfreeze my screen here. So we're going to evaluate determinants of 2x2 and 3x3 matrices. What the determinant is it's a single number based off numbers that are in your matrix, and we use it for a lot of different applications. And you're not going to see all of those today, but we will see a little bit. So on this first one, I'll show you exactly how this works. You start from the upper left hand and go down to the lower right hand like this, and we multiply those numbers. So 2 times 7. And then you subtract these two numbers multiplied together, which it would be 6 times 9. And this is how we get our single determinant number. So 2 times 7 is 14. 6 times 9 is 54. So 14 minus 54 is negative 40. So you will end up with a single number. And there is a significance to whether it's positive, negative, that we'll look at when we do inverse matrices. There's a significance if you get 0. And then sometimes we'll actually use the determinant for different applications. There's a lot of different uses for it. We're just today trying to figure out how you get the determinant, and then we'll move from there. All right, so we've got 3 more 2x2s to look at. So here's the process. We're basically cross-multiplying with a subtract. So we're going to take negative 1 times 2, and then we subtract negative 5 times 3. And it's not a bad thing to write all that out because there's lots of negatives to keep track of. So negative 1 times 2 is negative 2. Negative 5 times 3 is negative 15. And then I'm subtracting that, which means it's negative 2 plus 15. And the determinant then for this matrix is 13. So sometimes it'll be positive, sometimes negative. And sometimes you'll get 0, and like I said, we'll talk about the meaning of that more in a little bit. All right, so let's just do a couple more. So on the next one, we would take 3 times 9 minus 7 times negative 2. So it'd be 27 minus negative 14. Since you're subtracting a negative, that ends up making those add, and we get, what would that be, 41? And there's your determinant. And then this last one is special. All the numbers are the same. So if we thought about it, negative 2 times negative 2 would just be 4. And then we're going to take negative 2 times negative 2, which is 4. And on that one, we get 0. So we've seen some where we get negatives, some where we get positives. Sometimes we get 0. And that's how you do the determinant for a 2x2 matrix. So 2x2s are pretty straightforward. We can only do a determinant for square matrices, and we will only do 2x2s and 3x3s by hand. All right, so let's see how this will be different for a 3x3. So for a 3x3, there are a lot of different books that show you a lot of different methods. The method that I find the easiest to explain is the one that my math teacher taught me back when I was in high school. So what you're going to do is we're going to copy the first 2 columns over next to the matrix. So I'm going to have 4, 8, 2 again. That was the first column. And 2, 1, 5. I know you're wondering, why are we doing that? You'll see in a second. So what we're going to do is sort of like what we just did with the 2x2, but there's going to be a lot more to it. So we start from the upper left-hand corner and go this way, and you're going to multiply. So 4 times 1 times 1 is 4. So we're going to write that down. And then we're going to add to that 2 times 6 times 2. So 2 times 6 is 12 times 2 is 24. And we're going to add to that 5 times 8 times 5. So it'll be 40 times 5, which is 200. All right, now we're going to put some brackets around that. All of that will end up being equivalent to what that first number was on the 2x2. Then we're going to subtract what we get from going the other direction. So if we go this way, we'll have 2 times 1 times 5. So in another bracket, we're going to have 10 plus 5 times 2 times 4. So 5 times 6 times 4. So 5 times 6 is 30, times 4 is 120, and then 1 times 8 times 2 is 16. So you want to add these up in the brackets first before you subtract. So in the first bracket you get 228, right? And then this would be 130, 146. And then we subtract those. So what does that come out to be? 82, is that right? I think so too. So if we didn't mess up any of the math, the determinant for that one is 82. So it's a little bit more involved. In a lot of the textbooks, they just have you work with the original matrix, and they will actually have you cover up one number and multiplying others, and it gets really confusing. This is the least confusing method that I've found. So just know if you do this in college algebra later, or if you're taking an applied physics class where they use matrices, something like that, they might show you a different way to do this, but this will still work. All right, so on the next one, I'm going to copy the first two columns over, and we'll do the same thing. So first we go this way. 1 times negative 4 times 9 be negative 36. We're going to add to that 3 times 6 times 3. So 3 times 6 is 18 times 3 would be 48.
It's 54.
54? I did that wrong. Yeah, because it'd be 9 times 6. Sorry.
54.
And then, good job for paying attention. 2 times negative 2 times 1 would be negative 4. So I'll just write that as minus 4. And then we're going to subtract from that everything going the other direction. So 3 times 4 is negative 12, times 2 is negative 24. 1 times 6 times 1 is 6. And then this would be 3 times negative 2 is negative 6 times 9 is negative 54, if I didn't mess anything up there. So now we just have to combine all of that together. I'm just going to check and make sure we haven't made any mistakes.
A matrix, what would doing this give?
So I talked about that while you were in the bathroom. I will explain more later. So just hold that thought. You missed a little bit of explanation. All right, so this one comes out, the first number comes out 14. And then if I do what's in this bracket, it comes out negative 72. So 14 minus negative 72 is 14 plus 72, and that is 86. So one application of doing a determinant is finding area of various shapes. So I'm going to show you a trick where we make a matrix to find the determinant. To find the area of a triangle, and then I will extend that idea to something that's not quite a determinant that you could use for other polygons. So this slide right here is basically informational. They have 3 points on this triangle. They're just calling it x1, y1, x2, y2, x3, y3. And you put the points across like this into your matrix, but it has to be a square matrix, so they fill the extra with ones. And what this determinant would do is give you the area of a quadrilateral that has dimensions, and we take half of it just like you would on the normal formula for a triangle. Half base times height. This basically gives you the base times height number. We're going to do half of it. The plus or minus basically is to change the answer to positive. So if you get a negative number when you do the determinant, then you would assume we're putting another negative in front of it to change it to positive. If it comes out positive, you use the plus sign. In general, they have that there just to let you know, switch the sign so that it's positive. So we're going to try this with an actual triangle down here. Now when we set up a determinant, they take the brackets off. You can see over here, they just have these lines. Those lines indicate that they want the determinant without actually writing it in matrix form with the brackets. So that's just a little detail that I neglected to explain at the very beginning that I should have done. If they take the brackets off and just put like absolute value bars, essentially that's telling you, hey, find the determinant.
Plus sign is going to be positive, right?
Well, it could come out either way. We always change it so it's always positive. So you think of it as being an absolute value, we want that positive answer. All right, so we just start off with the 1/2, and then we'll use the absolute value bars to show that we're doing the determinant. So let's just do the top point, which is 4, 8, and then I'm going to use a 1 to hold that place on the end. Then we could do 8, 4, and 1 for the second point, 2, 2, 1 for the third. It does not matter what order you put the points in as long as the x and y are next to each other. So the 1/2 we'll do when we get all done with everything. So just remember that we have to do the half. So we would, I guess I ought to write out my other two columns. So we're going to rewrite the 4, 8, 2 and the 8, 4, 2. Seems like a lot of writing, but I promise this is the easy way. So we're going to take half of whatever comes down here. So we're going to have 4 times 4 times 1, so that's 16. 8 times 1 times 2 is 16. And 1 times 8 times 2 is 16. I don't think it's always the same number, but it happened to be this time. And we'll subtract going the other way. So 2 times 4 times 1 is 8. 2 times 1 times 4 is 8. And then 1 times 8 times 8 is 64. So 16 and 16 and 16 make 48, I believe.
Yeah.
So we're going to have half of 48 minus, and then 8 and 8 is 16, plus 64 would be 80. So we have half of negative 16. And remember, we want to change it to positive, so our answer would be 8. Did I make any mistakes? That doesn't look right. Yeah, it does. Okay. So
If you already used the 1/2 48 minus 8, would you have to not half the 16? Because 48 minus 8 is 32.
So I haven't done half of that. I did the parentheses first.
Oh, it's negative 32.
That is?
Yeah.
Well, then
The
why
answer
did we
is
say?
16.
Okay. Thank you. You're right. So that subtraction was wrong. I got ahead of myself, and the answer is 16. Thank you for paying attention. All right, so that is method 1, using the determinants. If you get into bigger polygons like quadrilaterals, pentagons, hexagons, it gets a little cumbersome to try to make it into a square matrix and do this, but there's a process that's very similar that we can use. So I've tacked that on. So you could say that this is method 2, if you will. And what that is basically a plus or minus half, and then we do the numbers vertically. So we have 1, 3, 3, 5, 5, 2, 3, 0, and it's not a true determinant because this isn't a square matrix, but we do the same math, and you don't have to do extra columns, which is nice. So you would have 1/2 of whatever we get here. So let's do that part first. So 1 times 5 is 5. 3 times 2 is 6. 5 times 0 is 0. Oh, there is an extra thing. Okay. Sorry, looking at my notes going that something's not right because I have to use this 3. So what they do is on the end of the absolute value, we don't copy both columns, but you do copy the first one, just to make sure that we get to use all the numbers on the top. So here we go. So 3 times 3. Sorry about that. I'm not on my best game today. So we're going to do 1/2 of, so 5 plus 6 plus 0 plus 9 minus, and then if we go this way, it would be 9 plus 25 plus 6 plus 0. So if I do what's inside here, this comes out 20.
And then the other one comes out 40.
And the other one comes out 40. So 20 minus 40 is negative 20. So you have half of negative 20. We change it to positive. We end up with an area of 10. So it's kind of like a determinant, but it's not exactly, but it's a method that you can use. The other applications for using determinant are when we want to do inverse matrices, and they go with a lot of different story problems that we've used systems of equations for in the past. So we're going to see how that all ties together over the next couple of days, but a little bit of information on how you can use a determinant here, but there are lots and lots and lots of different ways that it is used.